Alright, so we just completed A, now we're going to do B. And here it is, B. And it's basically the same process, just for different, I'm going to do it on a new page. 1 second. Actually, let's just get rid of all this stuff. Alright, so we're going to do B right here. Paste. We don't need this anymore. So we don't need Na. We don't need the sodium anymore. So now we're looking at chlorine. So we write Cl2, and that yields 16. Oh yeah, but that we need 78.9. So let's look at this. The use of 16.3 grams of chlorine could theoretically produce how many grams of iodine? Alright, so let me just get my pen. And we're going to do this in black. Start off with black and move forward. Alright, so what I'm going to do first is I have 16.3 grams. Of chlorine. Oops. And I want to get the moles. So I'm going to multiply that by 1 mole over 70.9 grams of CO2, which your professor gave you. It's actually got it from the periodic table. It's right here. All right, so now different color. I'm going to use red. These guys cancel, so we get rid of the grams, and I just now have to multiply across. So I get 16.3 divided by 70.9, and I get moles Cl2. Take out my calculator. The number of significant digits here is 3. So 70.9, 0.229, so that's equal to 0.23 moles C2, Cl2. Okay, now I go down. So I take my 0.23 moles. But I don't want Cl2, I want iodide. This is a 1-to-1, right? Because if we go up here and look at the balance equation, there's 1 Cl2 and it gives you 1 I2. So that's nice. So all we have to say is that, well, we're going to multiply it across and it'll just be 0.23, right? That's all it's going to be is 0.23. So it's easier than our other one, right? Oh, whoops. What am I doing? So 1 and 1. I mean, you don't have to do this, right? Like I'm just doing it to do the same steps. But you see that it's the same. And then 1 times 1 is just itself. 0.23 times 1 is just itself. So it's I2. And now we just use our relationship. So we take 0.23 moles of I2, and we multiply it by the grams over moles, right? Because we want to get rid of the moles. And we know that 1 mole is equal to 253.3, which I will have to double check. Sorry for that sloppy 3, but I just want to, 253.8. Change that to an 8. grams of I2. Put it in the calculator. 0.23 times 253.8. And I get 0.37 grams of I2. Alright, so we have the next question is actually kind of straightforward. So the limiting reagent question, all it's asking for is which one of these is like which one of these yields is the we only have a little bit of, right? Like which one of these kind of like we don't have enough is kind of like it's holding us back, right? Like you know when you have a recipe and you have to have like I don't know, I want to think of something simple, but like if you have like a recipe that has 3 different ingredients and you only have so much of one ingredient, like like I saw a really good video where the guy talked about here I'm going to show you really quickly. So let's say we're making s'mores, right? And s'mores has 3 ingredients. So it has a graham cracker, it has chocolate bars, and it has a marshmallow. And to make a s'more, I don't know if you've ever made a s'more, but you take 2 graham crackers. I only use 1 chocolate and then 1 marshmallow. And you basically make a sandwich with these things where the graham cracker is the bread and the chocolate and the marshmallow go inside, and you melt it. Like you could put it in a microwave, or some people do it with a campfire, blah blah blah. But anyways, let's say we go to a store, and in green is a store, and I buy 5 graham crackers, like let's say 8 chocolates, and then 7 marshmallows. Well, if you look at this, right, because the graham crackers, like, look, if I use chocolates, according to the chocolates, 1 chocolate makes enough for one s'mores, and 1 marshmallow makes enough for 1 s'mores. So if we use the chocolates, I could make 8 s'mores possibly. If I use the s'mores, I could make 7. Unfortunately, I only have 5 graham crackers, right? So how many can I actually make with 5? I can only make 2 s'mores. I can only make 2 s'mores with graham crackers. So our limiting reagent here is the graham cracker. You can't make more than what you have, and we only have enough for 2 because of the graham cracker. We have enough for 8 with the chocolates. We have enough for 7 with the marshmallow. But only 2, and so that's what we have to work with. So our limiting agent is the graham cracker. We only can work with 2. So now they're asking in the second to last question, what's our limiting reagent for this case? Well, what yielded us less? So if you remember, NaCl, we were only able to get 50 grams of iodide. And we just found out with Cl2, we were able to get 58 grams of iodide. Well, that's nice, but we can't use this one. We can't do 58 grams because we don't have enough of the NaI. So we only have enough for this, so we got to cross this baby out because that's a pipe dream. We don't have enough of these guys to make it. So the answer is our limiting factor or limiting reagent is NaCl, this baby right here. And now that we know that, right, we know exactly. So here, they said if the actual yield is found to be 80%, how many grams of I2 are produced? Well, we're going to take our limiting agent, which is 58, because we know that that's the lowest we can go. And we're going to say, okay, 0.8 times 50 grams. And that should give us 40. We can only yield 40 grams realistically.